If A1, A2, A3, and so on up to AN are in AP, where AI is greater than 0 for all I, then show that 1 over square root A1 plus square root A2 plus 1 over square root A2 plus square root A3 and so on up to 1 over square root AN minus 1 plus square root AN is equal to n minus 1 over square root A1 plus square root AN. From an AP, the first thing that comes to mind is the common difference. So here the common difference will be equal to either A2 minus A1 or A3 minus A2 or A4 minus A3 or so on. We can say AN minus 1, right? So D is equal to all of them. Now let's think how we can use this information in this given equation. On the left hand side here, we see that we have A1, A2 in the first term. In the second term, we have A2 and A3. And similarly, in the last term, we have AN minus 1 and AN. But they are under the square roots and they are not in the form of A2 minus A1 or A1 minus A2 and so on. To get rid of the square root from the denominator, we can rationalize each term. And before we rationalize, we can rewrite all the terms. So the first term here, which is 1 over square root A1 plus square root A2, can also be written as 1 over square root A2 plus square root A1. And now if we rationalize with square root A2 minus square root A1. So rationalizing the first term will give us square root A2 minus square root A1 over, and the denominator is in the form of A plus B times A minus B, which is A square minus B square. So we'll have square root A2 square minus square root A1 square. So you have square root A2 minus square root A1 over A2 minus A1. So the first term, which was 1 over square root A2 plus square root A1, is now in the form of square root A2 minus square root A1 over A2 minus A1, which is equal to D. Similarly, we can prove that the second term will be 1 over square root A3 plus square root A2 equals square root A3 minus square root A2 over D. And same way we can find all the terms, and the last term, which is 1 over square root AN plus square root AN minus 1, will be equal to square root AN minus square root AN minus 1 over D. Adding all these terms will give us the left hand side. So the left hand side now is equal to D is common denominator, so we can write 1 over D out. The first term, which was square root A2 minus square root A1, plus the second term, which was square root A3 minus square root A2, plus, and so on. And the last term, which is square root AN minus square root AN minus 1. Here we will observe that starting from A2, all the terms will cancel out except square root A1 and square root AN. So square root A2 positive and negative will cancel out. And similarly, there will be a negative square root A3, which will cancel out with a positive one. And same way, we'll have square root AN minus 1 and negative square root AN minus 1, which will cancel out. So eventually, we'll be left with 1 over D times square root AN minus square root A1. And here we can rationalize this and write it as 1 over D times AN minus A1 over square root AN plus square root A1. 1 over D times, we know that AN is the first term, A1 plus N minus 1D, and A1 is A1, so negative A1, divided by square root AN plus square root A1. You can cancel out A1, and after that we can cancel out D. So we are left with n minus 1 over square root an plus square root a1, which is equal to the right hand side.